This course will teach you to build a powerful, enterprise-grade AI system that prepares high-quality training data for tasks like creating chatbots or summarization tools. This isn't just your average AI project tutorial. IUSing will teach you about Python architecture, asynchronous data pipelines, and prompt engineering at a level you've likely never seen before. You'll learn to handle errors like a professional and develop a system that is both scalable and robust. The end result will be a unique project that will make you stand out to any interviewer.
What I'm going to show you, the project which has never ever been developed or showcased on the entire YouTube. And this is the enterprise level project. Most machine learning projects which you do are absolutely piece of shit. A Colab notebook, some Titanic data set, some production grade project, some MLOps project and whatnot. And what you do, you train a model, you get a fancy accuracy score, you just try to make them in a good folders, try to use some sort of documentation into the code, and then you're done. And that's the problem. Most of the companies who builds real AI and ML products does not really operates like that. And that's not how you get hired. And in my terminology is what you have built, it's not a system, it's a screenshot project that you screenshotted something and then you showcase that thing. It's definitely not a system. Let me show you the truth. Companies do not even care that what models you have trained on, what models you have fine-tuned on, etc., etc. They care if you can build a pipeline that can scrape live data, cleans it, feeds it to the model, tracks cost, and ships training data at scale. And that's where the jobs are. And now I have come with another great enterprise grade project that does not only build a model and then you can use that to get a fancy accuracy score and done. No, what we're going to do in this project is build a system that prepares the training data set which can be fed into multiple tasks, which is preparation of a chatbot, preparation of a summarization bot, and etc., etc. So we're not building that how to build a summarizer or chatbot. We're building a system that can generate the quality training data set which can be used for training of those specific tasks. Insane, right? And we'll be not doing this literally. We'll be doing this into full-blown enterprise-grade setting. I've worked on enormous number of enterprise-grade projects and I know what they will look like. And I bet you have not seen ever like this, ever, on entire YouTube on how these enterprise grade level projects are built. And I have divided this project into several 12 to 14 steps. And what every step does is following. And I am going to help you build from its scratch step by step with a video explanation as well as a written explanation in the PDF format which has been beautifully crafted just for you. So what you learn into this entire project? One is of course that you'll be building a system that generates the training data set. We're building tools like chatbots, summarization tools, etc., which is not so common project. But more importantly, what you'll be learning is Python architecture, how to develop the asynchronous data pipelines, prompt engineering at scale, real-time monitoring, Streamlit dashboards, error handling like a professional, and really how to develop something so scalable, so defensive, and an enterprise-grade setting, and much more. And you'll finally have a project where interviewer will literally say that, wait, did you build this? Because this has never been produced entire on the internet, and then you can just copy and paste the entire framework which I have taught into different other projects and build your own enterprise grade project and showcase that as one of the one class project which one has ever developed. Let's get started with this.
Hello everybody. So let's start off with the first step. And as I said, this project I've divided into several steps and I want to go step by step and break down every part of it super simply that anybody could understand with the real world examples. So the first step is, let's assume that you go to any places, right? Any factory or anywhere. There's a main entrance, which is always there in any factory, right? Where visitors comes in and, there's a big plate written as a main entrance over there. So think of that as the init.py. So in our project, we have a file known as into the source file in the training data robo, init.py. And that's what our starting point is. We want to understand that where all things initialized into this training data curation bot, which is an enterprise grade training data creation bot for LLM training using certain tools. So understand this in a way that when you go to the Disneyland, let's say when you go to the Disneyland, you don't just walk into random buildings and then take the rides and stuff like that. First, you go to the main entrance first. Then there's a reception desk that tells you, okay, what rides are available, what rides are not available, what you can do, what you can't. They give you a map showing where everything is so that you can roam around it in the amusement park and hell lot of things. Correct? So what we usually do, I'm just going to check, yeah. So what we usually do is Nattira.py is exactly the same. What it does, it gives you the main entrance so that any enterprise grid that you first visit me, I will tell you what things are available into me, what am I, what I'm doing, what are the rules, what eventually this whole project represents, and everything. So let's break down every bit of this particular file, because this file is pretty important that you can also replicate this into your other project. Is the first one is that this is a good tendency to write about what the project is about, which is welcome documentation. The welcome documentation means that even if you go to Disneyland, that you see a huge board about that particular thing. Same way it happens, a huge sign that welcome to the training data robo factory, which is training data curation bot, and then a little bit about the description about it. Now, why does it really matter is it tells about your particular project in a way that nobody does. And this is a usually good sign to write about your project as much as possible. So it's like a welcome to the training data robo factory. And what it does, it tells the visitors who are coming to your project that's saying that, okay, this is a smart computer training data. And just like McDonald's or probably the Disneyland would have something like those seats. Then once you have the big sign about that particular thing, then you have those metadata. Now, information card, what we do into that, like we should know that who all people made this project, how to get help if anyone gets stuck into that project, how we can track different versions of this project, etc., etc. when you update your phone or when you add new features and stuff like that. And that's what matters when you actually look at the factory metadata, and that's what really means. The version, the author, you can also write your name over here, the email, and the description about that particular project. It is as simple. All these things really, is very, very important at any enterprise grade setting project, because nobody does it. And my tendency is always to tell you that, okay, what nobody does it, which is very simple, but still so powerful at today's world. Now, we go to the next one, which is what we do. We bring all our imports, which is all our important parts of our file, into a tool, which is bringing all the tools so that in Disneyland, you go to reception desk, they tell you the different rides which are available. You go to a restaurant, they tell you different menus, foods options which are available, right? That's what we want to do. We want to make this as a reception desk. Okay, it knows everything which it has. For example, in the course, we'll come to one by one, but we have a settings, which is the config file. And then in settings, we have the, if you truly see over here, which is the settings where we instantiate. We'll come to what all these things means in a bit, but we will import the settings, which is core imports, which is very important. Because we are also logging every step, Of course, we could have used some simple logger, but I wanted to have my own logger because that's more accurate. I can apply any customization. So, which is logging, where you can literally log anything, whether it's logging any completed operations, failed operations, and stuff like that. Then we'll come to the code more in detail later on. And then you have training data bot error. So what does it mean? First of all, settings means the instruction manual tells our robot how to work, which is what are the settings to be have. Just like in any account, you have the settings, right? The same way it happens. We'll come to those settings in a bit. And then you have the logger. What it does, logger is very simple. Logger actually is a notepad that writes down what robot is doing, whether it's error, any good pass and stuff, whatever it does, it just journals it down. And then you have training data bot error, whatever bot we are having, it's an alarm system which tells us when something goes wrong, and that is more important. We'll go to these drivers into more detail later on, but this is the whole point. Now, in simple terms, because I told you that I've written tons of examples, there is one instruction booklet like settings, which we have imported, which is the settings over here. And then we have imported where you might take about notes what you're doing, which is the logging, where you log every step. We'll look at it. And if a freeze breaks, you need to know the error system. You need to know what error eventually happened, which is the error system, which is the training data bot error, which we have. It is that simple, right? And then once you have these settings, which is settings, what you're doing, and then probably anything alarm system, what you're going to do is you're going to bring the actual robot to work. And that's what we are also do. So our trained data robot over here is our bot.py, where we have imported. This is like an actual part, which is the most important part, is like our main robot that does all the work. For example, it's like bringing the factory manager to the front desk so that we'll come to what this trained data robot does, but at every reception, you have a manager who works for you, who's there for you. Now, when someone wants to use your project or use your factory or go to Disneyland, they talk to this robot. Now, what you should think of it is whenever you're going to a restaurant, you're asking for a manager, you're calling customer service, getting the main helper, going to the principal office and meeting the principal, the same way you come to this and then you meet my training data robot. As simple as that, right? And then you have our most important stuff, which is because this guy is a manager. Manager has people inside it. And that's what we call as a external modules, which you're going to import. Now, what it does, which is specialized workers, because we, as I said, we can load data, read PDF file, web loader, PDF loader, like anything comes PDF converted into training data, anything given links converted into web to training data for LLM, anything worker who can read text files, worker. And this one, even in the manager, you have the boss who will decide which worker to use, which specialized, let's say a user comes and says, hey, I have this PDF. Let's say I have this file. The unified loader will figure out, okay, if you have a PDF, I will give it a PDF loader. If you have a TXT file, I'll give it a document loader. So it's like an hierarchical system, which eventually tells us, okay, this is what we want to do. Is a manager, which is training as first task, and then training data robot tells the unified loader that, hey, this is the file which this guy is trying to convert this into a data. You can talk to any of these three. And then unified loader gives to the right loader over there. And then we have another loader, which is the tasks, which is more specialized tasks, which is worker who makes questions and answers. So once somebody loads the data, it gives to the another worker who can generate questions and answers. Worker who sort things into categories, workers who make short summaries about those instances, and the instruction sheets for workers, which is the task template and how this should be done for all these three workers. So I hope you're understanding the whole thing. It's like a team of agents talking really to each other. So I've explained, which is PDF loader is something workers who are really, really good at reading files. Web loader is worker who's really good at reading websites. Document loader who reads regular text files regularly. And it's unified loader, which is a supervisor who decides which worker should handle each job. And then you have task creation department, which converts that loaded document into actual substance. And then we have three different ways to do it: QA generator, classification generator, and summarization generator. And then you have, just like how you have a supervisor, you have a task template into this case. The task template will go to each of the methods step by step. What it does is a recipe card that tells worker exactly what to do and in what format. So you have the entrance, you have the guys, you provide the services with the task. Now what you need to do, you need to provide them the support and services, right? And that's what it leads to another one. The decoder client, which we have over here, is nothing but the internet detective, which just finds information from the websites. And we are using decoder for this. So we find information from the website. And then you have a text preprocessor. What does text preprocessor means? It converts those information into a very nice looking text so that our task creators can actually understand it. Then you have a quality evaluator, which truly understands that everything is working fine enough. And then there's a dataset exporter, which packages everything and exports it for our customers. Completely makes sense, right? Now, this is how I wanted you to understand that how you can think of it as a more managerial term. So I hope it makes sense till this point of time. Perfect. Now, we go to the next one, which is, let me just go to our next page. Now we come to the actual. So now you need to showcase, right, at the first step, like a menu card, that what customers can buy. Now, customer can buy the core part of it, which is the training tab or the settings related to it, to write an alarm system. What are the sources you can get the data is these things. What are the tasks they can buy, they can do, and what are the services which they can opt for, like a complete package. For example, the store can have thousands and thousands of things. but the front of it, there's a big poster showing the featured toys. And the list only shows the main thing customer usually want, and you can ask for other things, but these are the popular ones. And that's what we make it customizable, right? So the reason why we say that is because we have hundreds and hundreds of functions and classes and stuff like that, which is hundreds and hundreds of smaller codes inside our factory. But this list, which is out here, which is showcased to our public API definition, it should show the main tools which is usually needed. Now, if someone says from training data robot, which is this folder's name, import the training data robot, they exactly get what they want. So it's like a menu that's a restaurant, right? And showing the main delicious dishes and all. As simple as that to understand. So you might be asking, why do we really need this reception desk? Because I'm spending a lot of time in explaining it, I want to make it very clear. So let's say that you don't have this file. You don't have this entrance point. Customers would have to know exactly where everything is. For example, I want the robot from room 5, shelf 4, box number 2. Super confusing. Now with this file, they can just come to this folder and say that from this folder, I want to just import the training data robot, which can do my task. And the reception desk will give you that particular robot to work on. That's right. So if you don't have a robot, you do something like from data robot.bot to import training data robot. From there, .core.config, you import something. But if you want to use those things into any file, you just import from that folder, you import whatever you have initialized, all the things which you want to sell, these particular tasks and all these classes. As simple as that. So it's like you don't need the book for building 3, floor 2, section C, cell 5 and row 3. You just ask, where's my Harry Potter book? And then you get it. And that's what all matters. So here we go. Now let's say a customer arrives at a factory with some PDF file and TXT file, and they knock your door, which is pretty much easily importing. Like from data robot, you import that particular robot out there, right? You import that particular robot. Now reception desk, the file says, okay, here's your main robot. Then customer starts using that robot. So it initializes that particular robot. They create their own personal robot assistant, basically instantiate the class. I don't want to go into Python or details, but they instantiate the class. And you know what? This is just an example not written in the project. They give it some documents to read, which is bot.load documents. We'll come to all these features in a bit, that how we have built this and everything. And then they ask you to make the training data, which is the process document, which is tasks, which is there. And then they export the data set. As simple as that. It's like ordering at McDonald's. You import, you order a Big Mac, they make it for you, and then you get it. Pretty simple, right? And it's like building, and this is one of the most important design patterns that people miss. It's like building with Legos. Users don't need how our factory works inside. They don't need to know how our factory works, that at this shelf, no, come here and ask me, I'll give it to you. They just need to know what it can do. Like using a microwave, you don't need to understand the electricity, how it works. Easy to change. Now let's say if we improve a worker like making PDF loader faster, customers don't need to change anything. It just changes over there and they're importing the same file and everything. We are just going and improving a worker. The code still works the same way. You just switch going and changing and everything remains consistent. And it is easy to find because everything is important is at just one place, having your school supplies in just one backpack and not hunting around for things which you need around. And the really cool part in this is like magic trick. Customers think that they're getting everything at one place, but secretly we are going to have many different rooms to collect all these pieces, and that's what the magic piece is. Now, it's like when a waiter takes your order at a table, goes to the chicken, gets food from the 5 different stations, brings everything in one tray. You just see the final result. You don't see the waiter doing all of this thing. So I hope it makes sense. I hope it makes sense. This is super important for you to know about it. I've written some more exercises and I've written your own exercise which you should follow about it and think about what each robot would do, how students use them, or what makes it easy for this particular fun exercise. It's all on you. Do it by yourself. We go to the next step, which is our so-called heart of our factory robot factory, which is training data robot in the next file. But I hope this initialization file really makes sense to you. So we talked about our entrance gate, which is we prepared the entrance gate for the people to come in. Now, what we're going to do is we are going to build a factory manager, right? So that we have the desk so that no people can visit it. But now we want them to meet our factory manager, the big boss who runs the entire operation. Now, if our factory was Disneyland, let's understand this. If our factory was Disneyland, the reception desk, which is ini.py, would be at the entrance gate, but the factory manager would be itself the Walt Disney himself, the person who makes all the magic happen. Now, the training data robo is the smartest and most organized manager you have ever seen, and that's what our aim is to build. Is to build an amazing, smartest manager which you've ever seen. As simple as that. So, what the file which you're going to focus on is this particular file, which is bot.py. Now, what is this? What does this does? It's pretty simple, right? Now, over here, the manager, which we create a class, first of all, we have to create a manager, right? And this is a training data robot. And the class is main training data robot. What this does, the class provides a high-level interface for loading documents from various sources, processing text with each quality assessment and data set creation export. The 5 levels, the 4 levels which you talk about of loading, giving the processing and giving the right way, making sure that it's the right data, and exporting the data set in a way that it should. So, what we're trying to do is this factory manager has 4 main jobs, just like how a school principal have different responsibilities. Loads the document, process the text into useful information, make sure everything is perfect and fine, and package the final products for the customers. So let's go step by step over here. I don't want to go too much in detail, but let's go step by step. The first one, we import necessary libraries, which is async, path, and stuff like that. And I want to use this particular document for you to understand it better. The async IO is a super fast assistant, which is do many things at the same time. And we'll see that how this eventually helps. This is the tool which you're going to use for it. And then you have path, which is a GPS for files. So we can find files on our computer. And then you have a typing, which is a label maker. For example, when you are loading, so config is a dictionary, which contains a string over here, right? And then those are typing, which is from typing, we are importing the dictionary type, list type, optional, union of two types, any types, and stuff like that. So what it does is a label, which is the right types of information of what your data type of particular parameter is. And then you have UUID, which is a name tag maker, so that if we have anything, we use unique ID numbers. And then, of course, we're going to include our settings, because settings are the most important part of anywhere. And then we're going to write down everything, which is a get logger, basically the logger system which you have developed, which logs everything which you're doing. And then training data bot error, which is alarms anything, which is alarm system, which alerts when things goes really in the wrong direction. So we have imported it. And then what we're going to do is we're going to import all the workers at one point. First, we're going to import our unified loader, right? We're going to import our unified loader, which loads all the documents. Then we're going to import our decoder client for web scraping. Basically, it's like internet is scraping out there. And then we're going to import our AI client. We'll go to each of these managers one by one later in different steps. But we go to the AI client and the decoder client to go to step by step and figure out those details in a much better way. And then we have an AI brain, which is AI brain, which is AI client over here. And then the task manager, the work order organizer, to figure out, okay, where are we going to give anything to them? Then we have a text processor to process the text, whatever we have generated after the task has been completed. Then we have an evaluator to evaluate our particular task. And then we have a storage where we manage our database and export our data set in a way, which is the packagers. So all these workers with component imports, we have imported this from different files. So if you truly go and see from sources, if you come over here and sources, we have imported the unified loader. From decoder, we have imported the client, which is the decoder client, right? And you can see that ini.py. So even the decoder has the ini.py, so that we don't even import from here. From this folder, we just import the entrance thing, the interface that we just import over here. Even in sources, we have ini.py, you just import. We have already gathered everything. We just import from things from here, which is much easier, easy to find, and we don't need to tell which file contains what. I hope it completely makes sense. So we import, and you can see how simpler it makes, and all these errors of import errors comes and goes. That's what the whole point of ini.py for me to explain to you in that particular idea. Nice. Okay. So what do we need to do? What do we really need to do is the following. We go to the next one, which is H import with a superhero, as I already explained to you. And you know what? I'm a big fan of giving this, which is Captain America, Spider-Man, Iron Man, Nicky Fury, the Hulk, Hawkeye, and Ant-Man, right? Packages things perfectly. Now we go to the next step, which is the birth of the factory manager, where we initialize every bit of it, which is as you already know, I don't want to go into Pythonic detailed structures, but where we initialize every instances, which is we initialize our logger so that we can create our own personal things, personal class, instantiate that particular class for us. Then we have config, right? We initialize the components. Now for initializing the components, I'll come back to that where we initialize all the components. As you can see that we are not even doing here. We have a different, because we have so many things to initialize. We are not initializing there itself. We are initializing here, and then it initializes all the components and then says, okay, the training, and then we log our information, which is training data bot initialized successfully for it to work, right? Then, which is the component initialization. Now, what you can see over here that we have initialized every bit of it into a different thing over here. Now there is 3 special memory boxes, which is self, the documents, which is over here, which you can see. You know that we initializes all this for all our tasks. 3 special memory boxes. The first one is self.documents, self.datasets, and self.jobs. Now what does this do? I want you to understand it carefully. The document box which we have over here is a filing cabinet for all our homework, which is it files everything whatever we have. And then datasets box is trophy case which we have completed. And then we have jobs box, which is to-do list for all the jobs. And you will see that how eventually it helps in other instances which will work. And then if there's if there's anything, it says it failed to instantiate the bot components. This is the cause. And then we continue with that. Completely makes sense. Now we go to the first part of the one of the superpower for the factory manager, which is load the documents asynchronously, which is parallelly, right? To do many things at the same time. So load documents is our another superpower over here. And what it does, it reads books literally from anywhere. It reads information from anywhere, handles multiple books at once, and organizes everything perfectly. Now, how does this work? Again, pretty simple. You see, I don't want to go into too much of detail of making sure that you understand everything, because you can just copy and paste with GPT and understand it. But what it does eventually, it loads from different sources, and then it eventually gets you the right set of understanding. Now, then we have, I want you to go through it in more detail, but you can see over here that we have a loader which we have imported, and we'll go to that loader in a bit, that self.loader. It uses that self.loader to load a directory of the check if any source is a directory, and load from the directory itself, or load a single file or URL if there's a URL which you give. And we'll go to the loader when we go step by step, but I don't want to focus more on it. We'll go to the functionalities of all these loaders and how this is work and stuff like that, because this is a worker, and we'll go to the implementation of the worker in the next course of steps. And then what do we do? We store our documents, whatever we have created in our documents, this particular database out here, whatever we have taken out, which has loaded. Okay. And then what it does, it logs that particular thing. And then if it is an issue, it says the failed to load the documents. We have another superpower, which is the process documents. So once you have the loaded documents, what you do is process those documents. Now, what does processing those documents means? Processing those documents means is to create those training data for you to operate on, which is nothing but use all the documents if none is specified. Now, these are some default parameters, right? Then you create a processing job. Now, processing job is also what we have imported, and we'll come to that what this processing job means in a bit. But you use the processing job, and then you process those n number of documents, and you will see that how efficiently the code was written to even process millions and millions of documents in a matter of no time, right? And we'll go to each of the implementation in a bit, but I just want you to know about it. Now, all this processing, what it does, it processes those documents. Pretty simple, right? It gets all the documents and chooses the tasks, and then it creates a work order, basically a work order and then for each document as task, for each document and task, for example, for each document and task, it could give the make them in chunks for the each to be basically cut in chunks. And then it uses an AI client of ours. It uses an AI client of ours to create a training example using that chunk to create a training data. And then it creates a training example over here, right? And then it applies the quality filtering if enabled. As you can see, the client which you're going to use is this AI client, and our task manager is using this AI client, right? Completely understandable, right? This is not something super rocket science. It's just that you really have to keep yourself updated about what each task manager, because over here we're not directly calling the AI client. Instead, we're calling the task manager, which we'll study about in a bit. What this task manager does is executes this task one by one, and we'll go more and more in detail for everything in a bit. And then it applies the quality filtering, and then it creates that data set. We'll also come to this data set. What does this mean? Because this data set is a particular format which your data set will be stored at. And then it stores the data set, updates the job status, and outputs the data and says processing completed, generated this much examples as a logging file. And then it packages into everything as a single data. So I hope it makes sense. Then we have another one, which is the evaluate dataset. Evaluate dataset is pretty simple, which is nothing but evaluate dataset gets a detailed report for you. And we'll come to those evaluation in a bit, and overall scorings as well when we study about what is the mechanism where you're using to evaluate the dataset. And then you have the export dataset, which exports the dataset into a particular file by contexting and saying, okay, I want to take this particular dataset. Tell me what the dataset ID is, which you have stored, and then use those dataset, update the dataset format, and dataset will be exported into a particular file. Correct? And then we have our another thing, which is the manager's dashboard, where he sees like a report card where everything which you can see about statistics and status. And that's how we were able to create a very nice Streamlit dashboard where we were able to see everything out there by using this statistics column, right? Statistic report. Now, what does this do is it prints out, okay, what are the total number of documents, what are the total number of data sets, what job, what is the qualities, and everything out there. And we'll come back to all of this again so that you understand it again. But yeah, these were the few of the things. Now, you have the most important, which is you have other statistics, count by type, count by examples, which is not needed for you as of now. But then you have asynchronous, which is cleaning resources and closing connections when you close your Disneyland, when you close your project. So what it does, it closes all the database connections, and we'll come to what those database connection means. Again, we have imported all those aspects out there. Then what it does is, here we go. Yeah. Close loader, which closes all this loader and decoder client. It closes the remaining HTTP clients, AI client if it has a cleanup methods, and says, okay, I've closed this particular operations. Right? Perfect. Now we have this particular thing, which is the async context manager entry, async. So you can actually ascenter whenever you enter into the particular thing, and then exit whenever you want to clean up anything, where you're just calling the cleanup thing at once. The magic context manager, which I just explained you, what it does, what you can do, you can just async with as a bot, load documents, process documents, export, as simple as that. And bot automatically cleans up when they are done with it, right? For example, so which is quick process with the convenience methods, which is loads the document, process the documents, exports the data set in a particular format by looking at all these methods which was created down the line as a convenience method. And that's what we call as a magic usage, magic method, which is you just call that asynchronously, which is at one time, and then it awaits, loads the document, processes it, exports it, and gives you the final data set. And this is what we call as the express lane, which is one-click magic. One-click magic, which is crazily that you just call this method and it does everything for you. You don't have to do anything else apart from it. Right? So I know it was super comprehensive, the factory manager. I know it is super overwhelming at times, but What it does, the performance begins where you create a bot, which is your personal assistant. You set up your circus, which is bot hires, imports all the initializes components. It gathers the audience, basically loads the document, and then it processes those documents and exports that data set into a particular format, and then cleans it up and goes back to home safely. Now, why this design is pretty genius and why I really call this a genius design, which is single responsibility. The bot manages, not does the work, right? It just manages as this work. Workers are hired during setup and easy to upgrade. It uses only 4 main methods and just one to run, single line. Handle multiple jobs at the same time and remembers everything for reports and debugging. Right? So let's say that you have a company which is trained customer service and you have a data of customer service manual. You just await the bot to process those documents. You just say, okay, I want these data set types. I want you to evaluate it. And if the report is passed, export that data set. As simple as that for you to do it. Now, this is what we call it as good managers don't do everything. You just create a manager which is more powerful, which manages state. Async program is magic, which is handling multiple tasks at once and always cleans up whenever you're done. So by this, you're not just able to design better, but also organize programs, work in teams with clear responsibilities, who is working on what, debug by understanding data and scale applications for more, and think architecturally about complex systems. And the training data bot is the beating heart of the entire system. It's not the most complex component, but it's the most important system because it provides the interface. It connects all the pieces into a single workflow. And now I hope that you understand it. Now what we will do is we'll go ahead. We have visited the reception desk. We have met the factory manager. Now what we do, we go to the most important room, which is the blueprint department. Now blueprint department is having all the instructions for our entire robot factory, which is step 3, which we'll talk about now. Perfect. So we go to the next step, which is step number 3, which is the factory blueprints, and I name it as a code data models. So what does it mean? It really means that we have visited the reception desk. We have met the factory manager who does everything. Now what we need to do is we need to visit the most important room into the entire factory, which is like the blueprint department. So I want you to think in a way that let's say that you're building some Lego sets, and what you need is you need instruction booklets that show you exactly what pieces to use and how to connect them, like a blueprint architecture that, okay, this is what these kind of cards mean. This is what that kind of cards mean. This is the instruction booklets, etc., etc., etc. Now that is what is our models.py. This particular file really means that what it does, it defines the core data models for this. So what are data models? Let's try to understand a little bit more in depth. So data models are nothing but the recipe cards that tell your computer or our computer exactly what information should look like. Just like how a chocolate chip cookie recipe tells you. For example, the 2 cups of flour, not 3, not 1, exactly 2. 1 egg, 1 cup chocolate chips, all that thing. So it's like a recipe card which is out there which tells you what information should look like. For example, if I can tell you, PDF should look like PDF. Docs should be docs. TXT should be in TXT format. The available class type is Q&A generation should look like a QA generation and all that thing. So it defines what information should look like and exactly how it should look like. For example, it says that a particular document might be of any one of these ways or any one of these formats. A particular task type might be of any one of these. The quality matrix might be any one of these, etc. So what does it mean? A document must have a title, content, and source. A training example must have an input text and an output text, and every piece of data must have a unique ID and creation date. So that's what it entirely means. So let's go ahead. So basically what we're doing is we are defining the data structures which will be used throughout this application. And this is such an important thing and this is what is usually nobody teaches it and usually done in enterprise grade applications, is you define all the Pythonic models for all the data structures which is going to be used in the entire document. For example, we'll be uploading a document and document might be of certain types, etc., etc., etc. So let's go step by step and worry about the classes. The first, which is the master template, the foundation. Anywhere we start, just remember, is the foundation, which is the master blueprint. which is base class for all entities with the common field. The UID, the UUID, which we have imported, the unique ID for every field, where it is created at, when it is updated at, and what is the metadata associated with it. And then so that's what is there. And now I want you to understand another one, which is imagine you have 1,000 toy robots in a factory. How do you keep track of them? Is the old messy way. Hey, where's the red robot I made yesterday? Which robot? We have 50 red robots, etc., etc. So that's why we have this particular thing, which is just, sorry, I'm not really, okay. The one which I built after lunch. I don't remember what you had for lunch. That's why we do this of the superclass is what does it mean? The smart base entity way would be that every robot gets a unique ID, every robot gets a birth timestamp, and every robot has their own metadata, which is out here, and then which is color, red, etc., etc. Now you can find any robot instantly by using these entities, right? So then we have our another one, which is enums. Now what does it mean? Is just like how your school library sorts books into categories like fiction, science, and industry, our factory model actually will sort everything into clear categories: PDFs, documents, TXT file, MEMD file, HTML, JSON, CSV, and URL. Then as you can see over here, that we are also supporting URL over here because we have used Decodo over here, which is Decodo integrations. Now, what you can do, you can give us any website URL and we'll automatically extract the content for the training data. That's insanely powerful. So what jobs can our robots do? So that's what I say. These are the available job types. For example, you can do Q&A generation sort of data, classification sort of data, summarization, named entity recognition, red teaming, instruction response, and etc. So what do, you go ahead and you tell your robot that, hey, listen, dude, I just want you to read this Wikipedia page. It's about dinosaurs and make 5 questions about it. What does the robot say? Okay, got it. This is a Q&A generation task with a URL input. And that's what when we talk about the core data models, right? What we are doing is we are defining some sort of data structures for our application, which will be used throughout the space. Then we have, how can we check if the work is good? Then you have these parameters or data structures to check it is good. Toxicity, bias, diversity, coherence, and relevance. All these are the quality assessment matrix, which we have used over here. For example, I would like to make you understand in that way. Sometimes, yeah. So let's say like how your teacher grades essay on different things like spelling, grammar, activity, staying on the topic. The robot checks on the same way. Then we have the document family, which is our input data. Now, document family, if I could truly show you, okay, here we go, which is the document model. What should be our source document, which is going to come in, the title, the content, what is the source, whether it's a PDF, URL, and stuff like that. What is the doc type was language, encoding, the size, the word count, and the character count. All these things should represent the model. So, and then we have extraction method, the processing time it took to do it, etc., etc., etc. So let's say we have this scraped metadata, that what information we have scraped from it. For example, the website title and description, when it was last updated, what type of content, and all of this using Decodo integration API. And then we have text chunk, which represents a chunk of text from the document, where that chunk is then converted into Q&A by using our AI client, which will come to that in a bit. So you can see that we have the document ID, the content, start index, end index, chunk index, token account, the context, preceding context, the following context, and embeddings associated towards it, etc., etc., etc. Now you can also see that we also include something in a source URL, what it does, an original URL if it is from the web, that of course. Then we have the task template. What a task template does is what sort of task, which is what sort of task or work instructions has to be given, like how the recipe card should look like. So you can see over here that the name, what is the task type, the description, what is the prompt associated with the classification, and Q generation was of task. If there's task specific configuration, which we need to do, the parameters, what is they call the output length, max output length, quality thresholds, timeout, max retries, etc., etc. All these parameters which will be given to a model itself. Now, which is an AI provider which uses AI, which is the Claude over here, and then how much each training example costs to generate those things, etc., etc., etc. Then we have a training example. The training example which comes over here, a single training example, which is input text, output text, the task type, and then you have all these things to source it, the quality assessment parameters, and additional fields for different formats. You can either remove it, add it, does not really matters, but how does it really matter is you defining a data structure with the training example, and the data structure usually have this. For example, I want to think in one sense, just go to list data structure, right? Now, when you go to list data structure in Python docs, so let's just go there. When you go here, you have multiple things, multiple methods inside it, and a list certainly has some of the required thing which needs to be given. For example, list over here in the bracket you have to put it. So list is a data structure. Just like that, training example is our data structure. And simple reason we are doing this is nothing but to really, whenever you use it, this particular wheel, you'll be seeing that we'll be using heavily all of these things. We'll be using it there in the further steps. So a data set, which is a collection of a training example, what makes a data set a data set? Where you put the content, the statistics, what should be the ideal split, how you should export it in a particular format, and then you calculate the total number of examples. Correct? So all of this, and you know what, I have done other things as well, which I want you to figure it out, all those data structures by your own as well, because I just don't want to keep on telling you. But yeah, this is all we are doing. And then, of course, we have prepared the other thing as well. But what I want to show you is we can go to the quality reports, the processing job models, all these projection config, the file information and other utility models out here, which I want you to explore by your own. You can use GPT to truly understand every line of code, because I don't really appreciate now going into too much of coding details and just need to get the gist of what I'm talking about. So let's follow a real through example. So this is your source URL, which is the Wikipedia Artificial Intelligence. What a system does, it creates a document. Now document, you can literally call the document a data structure. So you can see over here that document, and sorry, we just got a little bit down. Okay, so document will have its own title, the content, the source, the document type, word count, and scrape metadata, which is scraped from it, right? Then what you do have the text chunk, and the text chunk document gets split into chunks, which is the text chunk, the data structure. You give the document ID, document.id, because you get the particular unique ID for that, the content associated with it, the chunk index, etc. Then you use the training example, the task generation, where it generates the right set of tasks. And it's a complete data journey which goes in throughout the end, which is the data set creation. So it's a complete database structure, data architecture for our training data factory. And what does this do is these blueprints ensure every piece of data which you're going to create is a consistent structure. The quality is tracked at every step. The costs are monitored for budget control, and web sources are remembered for provenance and analytics, which is possible with the rich metadata. Now, this is a blueprint. This is how it should look like. This is how the document should look like. This is how the data set should look like. This is how the processing should look like. Now what we do is we will see that how we can actually load and process these documents through our highway system. So let's work on step number 4. But what I want to talk about is the most important thing. We have studied from its basic concept, which is init, which initializes everything. Then we talk about blueprint. Then we talk about the training, the main factory, which eventually like a workflow. And this we end this step 3 with the blueprint. Is good blueprint makes great buildings. Our data models makes great training data because of these particular reasons. I hope it makes sense. Now we come to our other part, which is the document highway system, which is an amazing where we actually go ahead and load and stuff and work around our model actually. So now what we'll do is we'll go to step number 4, which is the document highway system, that how do we really load our documents, whether it's in form of PDF, URL, and stuff like that. So you remember our amazing robot factory journey, right? We have seen the reception desk, we have seen the factory manager, we have learned about the blueprints. Now it's time to visit the document highway system, that the super smart transportation network that brings all kinds of documents into just one factory. So think of it like this, that you imagine you're running a pizza restaurant that delivers to anywhere in the world. You need trucks for local delivery, ships for overseas, planes for fast delivery, and special refrigerated vehicles for frozen pizzas. Now, what you're going to build a pipeline that is like having one smart dispatch center that automatically picks the right vehicle for every delivery. For example, you have a pipeline which say, okay, this is a text, a PDF file, this is a website, this is a text file, spreadsheets, and many more. We're using this Decoder Professional Web Scraping API again integration, where you can literally scrape any content from any website in the world. Just give us a URL and we'll extract the content for you. So the amazing part, you don't need to tell it what exactly the document you're giving. It figures out automatically and handles it perfectly. And that's what is needed. You don't need to tell what is going to come. So let's go to our code. Go to the sources file and go to unified, because these are other documents. And what I want to do is I want to let you go to unified loader and imports all the necessary libraries, which we'll come to in a bit. But we have a base loader. What does base loader does? All this, so you can go to the base.py, and base loader is nothing but the abstraction of how all the document loaders look like inheriting the base class. Like this is the base class, like just like the foundation, right? That this is how it should look like. It should have a load single method. It should have a load multiple method and stuff like that. Load stream and others method. You can overwrite it and everything. So I don't want to get again Pythonic explaining you all this, but we have an abstraction layer which you build on top of it. So unified one, where we inherit those, and then you can see over here that we are writing the load single part of this particular class, etc., etc., etc. So you have this unified loader. I don't want to again get into too much of coding base, but what we are saying is we initialize any sub loaders, which is document loader, and then we have PDF loader. And if there's a decoder client, if the decoder APIs and stuff like that available, then you load the web loader, and then you say unified loader is using shared this out there, right? So we go to the next one. Now you can see over here that we have also more supported formats from a subloader, and then we take out the document type, which is basically the list of whatever the documents were supported, all the supported from the loaders which we have. So how this works actually, that your old confusing way will be, okay, I have a PDF file, okay, use the PDF file. I have a website, okay, use the web loader. I have a Word document, which loader should I use? The smart unified loader way, what it does, I have some document or website URL, no problem, I'll figure it out automatically, and that's how it is so powerful. So I want you to go to over here, which is nothing but our how it figures out those document types, basically the document detective process. And it is pretty simple if you truly see over here, which is select loader, which is select the appropriate loader for the given source, which is the source file, whatever the source file it may. So if it is a handle URL, if the instance starts with HTTP and stuff like that, it is a web loader. If it is handled file path, if it gets a file extension and then return to appropriate. The doc type is document PDF, you say, okay, PDF loader. If the doc type is getting into this, then you return a formal document loader. So this is how it is automatically figuring out that what it needs to and how it needs to do, right? And now, and you can see, is it a file, what type of file, and then you automatically fix it up. Then we have our star player, which is the web loader, which is web loader. What we're doing is amazing stuff. We're not using bright data because again, all these things really doesn't really make sense. Now, what it does is loads for the web content from URLs using Decoder's professional scraping service API, right? And it's so powerful. I don't want to get into too much of detail right now, but it's so powerful that it has an amazing ways of scraping it professionally using the APIs, intelligent fallback to basic scraping if it doesn't work, the JavaScript rendering and dynamic content, which is again super great. And then we have this bypass any bot detection comes in, rate limiting, or clean text extraction from any website in your particular format. So let's spend a little bit of time into actually talking about this particular thing. right? And I want you to, which is this is a professional web scraper which we have built, and you know what? This is the crazy thing which we have built out here. So I don't want to get into too much of coding again, but we initialize the web loader with a decoder integration which we have added. And again, I need you to do all this. So you'll be having a PDF document basically, which PDF document explains what things which you need to do. And also you can come to the readme.md, and readme.md tells you everything which needs to be done. What are the env things which you have to add, the APIs and stuff like that which you have to add over here, so that which you can use it successfully. And Decoder is super simple. You can just take their APIs from their website. That's super simple. If I can do it, then why not you? So the supported formats, if it is there, then document.type.url, because that's what we are dealing with. And then you initialize the decoder client, and which you have used. So you use decoder, which is the client which it passes over here. And of course, we'll be using this. And then when we will pass something, a client of decoder. Now, if the self.useDecoder is equal to true, then what we do, we say, okay, web decoder initialized as a professional client, failed to initialize. Then if there's an error, then web loader will use a fallback scraping, right? As simple as that. And then the use decoder will become to false. So if the decoder integration is not working, it goes to a fallback options. Now, fallback option, I want to talk about that as well, which I'm going to go, it's fetch with fallback. If the fallback is not there, then it just uses simple sort of, a simple basic sort of extraction, using the basic HTTP scraping, as simple as that. Doesn't really help, but if the decoder is not working, it just falls back so that it can continue to do some work. Now, if self is with self.decoder and decoder client, and it's initialized with decoder professional scraping API. That's it. Now, this is the web loader which I'm talking about. Let's go step by step of what eventually happens at every point. The real website. So let's assume that you have this machine learning Wikipedia pages. What you do, the unified loader will load the single. So basically you can see that we also have the load single method out here. And what this load single method does, if the instance does not start with that, then you say it's an invalid URL. But if it starts, you log that particular context, and then you say the load URL, the URL is this, the method is decoder. And if the method is not decoder, then say, okay, it's a fallback, like a logging thing, which is formal, which you're doing. Now, if the self.useDecoder and self.client, then fetch with decoder. So if self.decoder is true, and then you also have the self.decoder client is there, then what you do, you fetch using decoder. If that is not, you use the fetch with fallback. So let's go to this particular statement, which is the fetch with decoder. Now, what does fetch with decoder means? That you give this setup, you give all these decoders parameters, and decoder was once used to be called a smart proxy, but this decoder parameters, what it does is scrape those parameters, which is the the parameters which you need, the target, the local, which what should be the English, and the geography, the device type, the output format should be in. And then you simply call the decoder client with decoder client.scrape URL. And we'll come to that as well when we actually learn about this particular thing, which is the decoder client, which is still yet to come, where we literally have this, which is just a big one on scrape URL, and a big format of thing is over here, and we have developed a pretty great web scraper. Then, so we'll come back to that, but scrape URL, and you extract the content from the decoder response, and the content is in the results, you clean it and whatnot, and the content is failed, try to extract from the raw, which is the fallback option, which is the extract HTML text. And if we get here, the decoder did not return usable content, then we just return something out here, and then we have some fallback options. As simple as that. Pretty simple, right? So what happens that it starts with and checks it. Okay, this is the right thing. Then what it does, it uses the load single. Then it extract content with the decoder using the script URL method from the decoder client, which we'll study about. And then you can actually get the content. Machine learning is the content from the result. It's actually some sort of data structure, which you can get from result content, as well as the metadata, like a title, description, stuff like that. And then what you do, you simply create package as a document. And the package as a document is nothing but document, the title, content, the source, the document type, script metadata, created at, as simple as that. So what it does, from a simple website URL to perfectly structured package as a document, not just you're calling it like SE, it's just that you're literally creating a productionized grade, enterprise grade applications where you package it with the nice way. And this is how the whole scraping API looks like. I wanted to go in more detail because again, I'm just making you go through other things like load multiple URLs and all these features which I've added, extract titles from the content, close up, clean up, all these things I want to go by your own because all these things is also, I just want to talk about the right things for you to go ahead. So this is it about step 4. I hope it makes sense. We now go to so let me see if we have anything because we usually have it, which is okay, here we go, which is the multi-document loading because I was about to come over here. Now, multiple document loading means that what if you have hundreds and hundreds of websites to load? That's where our Decodo, again, Smart Convoy comes into play. You just put in the sources a list and then you use the load multiple, which is the load multiple URLs. And of course, you have you go to the client and when you go to the unified loader, unified loader, which I've created, and then I'll just copy and paste because that's way better. Load multiple, right? So what it does, it uses this load multiple thing and then it just takes out multiple instances. So over here, when we actually see it and then we go to web, then you can actually see over here that we have this load multiple URLs where you can literally load multiple URLs out there. So what it does, so basically it's as simple. You go ahead, you load it, you successfully load it, all these documents, and then you gather the tasks and then you get that up and running. Of course, I'm just trying to avoid any sort of technicalities explanation because if I get into that an hour will take for me to explain you out. But yeah, this is one of the things which you're doing. And what I want you is go through it one by one and learn about the code, which is the web. And then you have all these files created over here, which is one is the select loader. Then you have the load single, load multiples, and all that data out here, right? And then you can go to web, then where we are inheriting all those understanding, and then we are loading multiple concurrently. So you can see that we are loading multiple URLs concurrently, where you gives the list of URLs, the maximum current requests, and then you asynchronously load all these things. So of course, we'll come back to a little bit what is load with Semper means and how we're getting all this. But again, this can be easily understandable. But what you're trying to do is we are trying to cover any other features which can actually come into the place. So I wanted to explain about that, which is mixed content rolling. And what does it really mean? Which is, let's say the student gives us the sources. Our smart analysis understands, okay, so 3 websites are detected and 2 files are detected. It sends 3 websites to the professional web scraping API and 2 files to the file processing. So truck 1, which scrapes the Wikipedia with Decodo. Step 2, scraping IPCC reports with Decodo. The truck 3 does this, truck 4 does this. And then you have all the documents which you package in a document and then you send it over. Now, why our enhanced system is incredible? Because Decodo integration is for enterprise grade scraping. And then we have a small back which is always smooth, which is up and running, which is the most important part of it. And then we handle it very gracefully. We have unified experience, one just simple thing, and enterprise features like metadata, scalable architecture, quality validation, cost tracking, and stuff like that. So it scrapes any website, loads any file data, routes everything automatically, handles error gracefully, and provides rich metadata for the better content. And as I always say, the best highways connect everywhere. Our enhanced system brings the entire internet on all your files into one unified pipeline. Sorry, it's citing some latex error. I'm not sure why. So this is at about 4, where we are able to create a nice scraping API. And of course, I know that I've not went into detail. I would just want to understand that how I'm actually doing all this. Then what we're going to do now is we're going to go to talk about, we are done with the web. We're going to talk about PDF and the documents that, okay, this is how we load the PDF documents, but I'll get that a little bit quickly because of course I wanted to figure it out because I've written a 100-page document, not just to read it out. I wanted to read it out, right? So then we go to the step number 6, which is more interesting, and then we keep on moving on. So now we go to the step number 5. Now, step number 5 is nothing but a specialized document loaders, where what we did in the last step is we were able to create a highway system where we were able to create a decoder integration that is able to scrape any website, finds any figures of the file type, assign it to a nice one, and then we go ahead. So now what we'll do is we will go ahead and go inside the garage. So basically we have the smart highway system which automatically routes the documents into the right trucks. Now we need to go inside the garage and meet each specialist truck and build them basically. So a fire truck has ladders and horses for fire, an ambulance has a medical equipment for emergencies, and each vehicle is perfectly designed for this. So the same way we want to design each vehicle, each truck, who is going to be using our thing to load the documents, to load the PDFs, to load the web, to surf the internet, and even the master blueprint where the base model of the car, like every car has an engine, every vehicle has an engine, every vehicle has a brake, right? The same way you have this base loader where every specialist will be having these on top of that with their own mechanism of PDF loader, web loader, and document loader. So the master blueprint, as we spoke about, is nothing but our universal truck design. Basically, you have this base loader, and I already showed it to you over here, which is the base.py. And in that base.py, the reason why we need it, that without a master blueprint, PDF truck might work differently than text truck. Some trucks might be missing the important features, hard to add new truck types, chaos and confusion. Correct, right? All trucks work the same way from the outside. For example, if the ambulance is going on and then the fire alarm is going on, both are looking like a vehicle, right? So the same way we need to have the master blueprint of how it should look like. Like some of the most important features that everyone is having engine braking systems, everyone having same safety features. The same way, this base.py is like load a single document from the source. We have not implemented anything, but this is one of the feature which every specialist should have. Load multiple documents concurrently. So basically load multiple documents out there. Load stream, which is load documents as a stream, which is generator, right? And all these features like a base features, right? So then we have some of the, which we call as universal safety features, which is traffic control, which is parallel loading. We can load multiple things out here. So you can see so I told you in the last step that we'll come back to this again. So what does this mean? That multiple trucks can work at the same time. No traffic jams or system overload, basically building more lanes, and failed trucks do not stop the another, and maximum efficiency. As simple as that. Then we have this get document type, which eventually figures out what is the document type out there using this method. And then you have this format detection, as you can see, then document creation factory. Then if you go and then create a document where it creates a document instance with the standard metadata by looking at those and taking those documents which we have created. You can see that this document class is which we have created previously into our bot.py basically. And even if you go inside it, then we have created those particular details. So that is one. Now, I don't want to go too much in detail about what all this means, but yeah, I hope you get the gist of what we're trying to do. Is we are trying to have some universal safety features into our base pipeline for it to be able to control the basically parallel loading, some of the things which is universal safety features where all the specialists will inherit from this base class. So let's go to the first one, which is the text master, which is the document loader. So if you go to the document loader over here, which is nothing but documents.py, and you just see the document loader, and this is the document loader which you're focusing. And this class, basically what it does, the specialist what it does, it loads for the text-based document formats, which supports the TXT format, MD format, and all. And then it says, okay, supported formats are the following. And then we have this, again, you can see over here, the load single, the implementation of this, because every truck is different, right? So the load single is different over here. That says, okay, with log context, it loads the document. If the document type is TXT, it loads the text. If the document type is MD, it loads the markdown, all in all. So you will see that load text is also written over here, where we have written asynchronously load the text file, and then it loads the text file, then load the markdown. So we've created all those methods, and then we are calling based on the particular format, basically routing to the appropriate loader method, which is the multi-tool approach. Then you can go through, which is where we are loading the document, and then what we are technically doing. which is markdown handler. It marks down, then HTML text extractor, if there's any HTML thing, then JSON data converter, which you have done, and then tool 5 CSV. So even the document loader has multiple tools inside it, and then Word document reader, and all in all. So these were for a few of the document. Now we have this PDF export, which is the PDF loader. So I'll just a little bit zoom in and go to the pdf.py. And what this PDF loader does, it loads for the PDF's documents. And you can see over here that it loads the PDF document. First of all, it creates that document. And when you call that creates document, you can see that base.py really has this create document, and it creates the first of all document based on the PDF, right? And then extraction method, it PDF loader.pympuf. Now, it uses the asynchronous function. Again, you can see over here that the PDF, it loads singles, and the heavy duty PDF to work. And then this PDF extraction tool, which you have created out here. And you can also see over here that we have created the PDF extraction tool, which extracts the text from that, right? So I don't want to go into more coding details. I know you guys are great. You just paste on GPT and try to understand what exactly each line of code does. But I just want you to know the gist of what you're trying to do. And then you have the internet server, which is the web loader. So if you go to the web.py, and the web loader, which is over here, which loads for the web content from URLs using professional scraping APIs. And we have already talked about this into our last step. So it uses all those methods in the way, which is this website specialist. The first one which we load, which is the website specialist, basically the document type, the supported format for this class is nothing but the URL, which is website specialist. And then we have this web surfing process, which is just defining how to load that thing, and using the Codo, we were able to do the right thing. For example, asynchronously, we are fetching the URL content, we are visiting the website, check if it worked, what type of content is this, etc., etc., etc. And then we have this extract HTML text. If the Codo integration does not work, we use Beautiful Soup to make it work. And then we have other methods, other supporting methods out there. Now, how does all of this works? So let's say that you have the sources, which is textbook.pdf into a current directory, notes.txt file, data.csv file, and then a URL. So for the source and sources, the source starts with it, you use the web loader. If the source ends with PDF, use the PDF loader, or else you use the document loader. And then whatever you have instantiated that particular truck, you just call that particular load single and give the source of whatever it might be, and it will get you the right set of data from it, which is loading the document. Now, I want to talk about how is it different at all, and where it really combines, where it really, is brilliant. Is every truck, and when I say truck, every classes over here is expertly designed for its own document type. PDF truck knows about pages and fonts, web truck knows about HTML and URLs, the text and everyone. The perfect spatialization which we were able to create. Then we have a consistent interface that all trucks follows the same blueprint, and the blueprint is our base loader. And every method, they have the two most method, with load single and load multiple, with multiple add additional methods in their specialized based on whatever their object type is. And they all have a same output format, which is document objects, right? So we have also created the document object out there, and we were able to use that to be able to do some sort of task. For example, if you go to the core and our models, which we have here, this is our document object, output is nothing but in this particular format. So we did have the extremely good error handling, extensible design. You can add a new PowerPoint support. You can handle video transcripts. You can handle image. You just keep on adding by extending that base loader and just using that on and on without even going and change anything out there. So it's scalable, defensive, and readable at the same time. So I hope it makes sense. Now what we will do is we'll go to the step number 6, which is the text kitchen. Now what does this mean? That we'll be creating a text processing pipeline which cleans the text, cuts the document, counts the words, and packages everything for the next step, basically for an AI to convert that data which you have loaded and the process data to be able to create the training data set. You go to the step 6, which is the text processing pipeline. It is very simple. I want you to read all along, but what we're trying to do is once we have those loaded data, we now go ahead and convert that into much more clean text, cuts the documents into manageable chunks so that every chunk can be used to create a training data set, counts the words, and packages everything perfectly for the next step, which we're going to use. So the chef tools basically the master chef, basically the the initiating, basically what is the logger. We instantiate our logger for the preprocessor. The chunk size, basically each piece into a particular document should have at least 1,000 words, just like you cut your pizza into slices, right? And then each piece can overlap with the next by 200 words to give like overlapping pizza slices so no toppings fall through the cracks. So chunk overlap, right? Now, this is the complete cooking process, which is step number 1, clean the text. Step number 2, create the chunks. And step number 3, which is log them. As simple as that. So you can see the document over here as well, which I've created. This is the asynchronously processed document. Somebody has to call this. We call this two most important methods. We clean text and create chunks. In clean text, I've had the basic things where you remove excessive white spaces, you remove very short lines, you remove all those things. And then you have the create chunks, and this is the text chunk, which is the text chunked object, so that it outputs as an object, so that it remains consistent, whatever the data structure which we have defined over there. So document ID, the content, the start index, the end index, chunk index, and token, and then we append that into a chunk. Now, if there's multiple chunks, then you actually have the multiple chunks, and then you create every chunk into that text particular chunk object. Pretty simple, right? So what we're doing literally is we are washing the machine, where each machine is removing any white spaces, removing tiny lines. For example, the best example is this. So this is converted into this after cleaning. Then we have the text chunking process. So just like that, as I said, you're trying to eat an entire pizza in one bite, which is impossible. Same with AI. A book might have 100,000 words. AI can only process maybe 1,000 words at a time. So we cut the book into 100 perfect slices that AI can handle in a way intelligently, basically our AI client. And that's why we have a smart chunking algorithm. Now, what the smart chunking algorithm, I wanted to worry about the code, but later on. But what does this do? It creates the chunk out there. So I'll come to that chunk in a bit. For example, why do we need, this is the chunk. Now, I also talked about the overlap thing. So without overlap, you can see that chunk 1 is the dinosaur was walking through the forest when suddenly it heard then chunk 2. So the context is not being matched, correct? So the story is broken. We lose the connection between chunks. To have the connection between chunks, we usually have with overlap idea. Now, what does this mean? The chunk 1 usually have the dinosaur was walking through the forest when suddenly it heard a loud noise. When suddenly it heard a loud noise and got scared, then it looked around. So it took a context before and after as well to be able to make sense out of the previous one, which is the success, where we are able to get the context of the previous and the next one as well. So overlap working is pretty simple. You just, use that into the which I've seen that we are overlapping and creating that chunks in a way that really matters. For example, the document which I've created, the data set, the title is the Romeo and Juliet. Then this is the content and document type is PDF. It cleans that, it creates the chunk, and then the final result which comes out of it is the text chunk document of ID of chunk 001. The content of that particular is this. Then you have another one, which is the other chunk number 2, and then it goes on and on. So you have other methods which you can go and learn about it. But what we are doing literally, we are creating the AI optimized portions basically for AI to process and create the training data. Then every chunk knows exactly where it comes from, the parallel processing, memory efficient, configurable, handles any document size, graceful degradation, consistent output, which is in a particular format, and much more. So we have the complete journey so far. The step number 1 is the loading of the document. Step number 2 is the text cleaning, right? Step number 3, text chunking, where we chunked into particular several things. And then we now have chunks which will be given to AI to be able to process it in a way it should. So now we have another step number 7. So step number 7, what does this do? Which is the job assignment office. Basically, now we have the hell lot of things ready, which is the specialist who does the work. Now, any document which comes in, we should be able to create the task manager who creates the job templates, assign it to the right specialist, tracks the progress, handle multiple objects and projects at the same time, and keep detailed records, basically logs at the same task. And now that's what we're going to learn in the next step. So now we'll go ahead and learn about our step number 7. Now, step number 7, what does it say is that you have your everything ready, right? You have your factory and everything ready. But now we also need a way, once we load the document, once we process the document, we need a way to create something out of it, which is basically the data out of it, the training data, right? And that's why we'll create a job assignment office. So let's say that you're running a movie studio, and in that movie studio, you have different departments. The departments might be directors for filming, editors for cutting scenes, sound engineers for audio, special effect artists for magic, etc., etc. And then there's one production manager which decides which department should work on each scene and make sure everybody knows what to do. And that's what we're going to develop. We're going to develop a task management system for this project, which creates the job templates / job descriptions. It assigns the right specialists to do each job. It tracks the progress and makes sure everything gets done, locks down the projects at the same time and multiple projects at the same time, and keep detailed records of what really happened. So let's meet the production manager. So I want you to go to this manager.py, and when you go to the manager.py, you'll be eventually having the task manager, and this is the task manager where we initialize the logger, we initialize the templates, and then we initialize all the task generators. There might be multiple generator over here, the generation, classification, and summarization. So this is a production manager, and what it does, so I'll explain you in detail what it does, is you just need to go and say that I need QA generation. This task manager will automatically pull up all the QA generation and then get you the QA generation task done, right? So there are two things which I want you to know about: the task templates and the QA generation template. So the task template, if you have seen that in our core thing, we have developed in the models that what the task template should look like. It's like an object which represents what a task template would look like whenever we assign a task. That's the best practice, which you talked about, like a recipe card, right? And then, for example, let's say that you have a QA generation template, right? So task template, your name will be basic QA generation. The task type is the QA generation, the description and the prompt associated with that particular task template. So it's like a recipe card. So we have not yet still implemented it, but it's like a recipe card, which we are doing for classification, summarization, as well as the task template, which is like an object, which it tells, okay, what our really data looks like. The task templates should look like. So pretty simple, right? The step number 1, which we hold over here, is job request comes in, for example, text chunk, and then someone wants QA generation from a text chunk. So this is the text chunk which we create first of all. So let's create the text chunk first of all. And then we execute the task. The task is the task type QA generate from that particular chunk, text chunk, and then you give this AI client. The AI client is the one which is the AI brain, which converts the text chunk into the training data. And then you assign this. So what happens is finds the right recipe, finds the right specialist, and prepares the job. And then the specialist takes over that by calling the execute method, by calling that particular template, whatever we have, which is a get default template, which is a get the recipe card. Basically, it outputs that get recipe card. And all of this has been implemented over here when you go to the manager, and then you come over here, which is create template, get default template of particular template, and they create a basic template. The template might be of QA generation, and you can see that the prompt is also written over here, the description about that, and for classification, the prompt is also written over here, and summarization, the prompt is also written over here, right? So specialist takes over the results, which is execute, and then it goes ahead. Now, step number 4, which is the quality control and packaging, where we package everything into task result, which is another object where whatever the result comes out of it as a keyword result, it takes that up and running. So same way we have the several specialists where we have implemented that, the manager, which is base task generator. So this is the base thing where, as I say, this is like a blueprint. Now this blueprint will have a multiple, there's execute, the render. The same way you have the QA generation where it execute the method, and in that it processes those texts, and based on the templates which you have designed, the prompt which you have designed, and gives the prompt, the text chunk, and the task type. It might be, in this case, it will be the QA generation. This is the QA generation, then it returns the task result into this particular object type, which we have created in the models.py. And then same, you have a classification and summarization, which I have not implemented. Please feel free to go ahead and implement that up by your own. These are specialist departments which we have added. Now, we also have several smart features. For example, you can create a custom templates if you want to, not just focus on that. You can get templates by type. You can specify the particular templates and all that thing, which what I want you to focus on that, because all the details have been written into this document. My whole idea is to tell you how to read this document in a way which eventually works for you. So yeah, I hope it makes sense. Then this is a challenge. Now, the reason why I'm saying this, that what it does is this task manager export organizes all types of AI work using smart templates, assigns it to right specialists to each job, executes multiple tasks in a parallel for most efficiency way, and packages results like in templates way to be able to return. For example, if you just come over here, you execute task. Now, execute task takes in the task type, the chunk, and the client, basically AI client, and the template ID, if there's a template ID out there. That if you first of all, you get the template ID, whatever the template ID is there, or you create a default template, which is the default template which is out there. In the default template, you define the task type. The task type might be QA generation in this case. Then you get the appropriate date generator, and then you execute the task, which is template, the chunk, and the client. Now this executes the generator. Now the generator is an instantiation of QA generation. The QA generation generator, which is execute, really processes those texts. And then, now we'll come to that client in a bit, where how does the processing works, what is the mechanism behind it. But yeah, this is how eventually it is done. And then it finally says, okay, task is completed. That's how it does. Now it automatically figures out, okay, what given the task type, it automatically figures out what sort of tasks needs to be executed. I hope it makes complete sense. Now what we'll do is work about AI task generation, which is another part of it, which we'll talk about in the next step. So now we finally come to our step number 8. I'm extremely sorry, this is step number 9, but the previous step has been a little bit of some problem when I'm recording. So when you get the document, it will be step number 8. But kindly ignore the previous document. But however, you can also view the step number 8, which really makes you understand all the steps in more detail and stuff like that, more sort of task generators. So step number 9. So in step number 9, what we're trying to do is we're trying to create the training data. So basically now we loaded the data, we processed it, we created it into chunks, we have a task manager who assigns it to particular tasks. But now we need to create a client, AI client, where you always see that every generator expects a client, where an AI model, right? That's what we're going to do, like an AI brain, which is having access to the greatest models and then try to connect it. So that's what we're going to do today. The AI client is our factory's creative intelligence center that connects to powerful AI models. In this case, we'll be connecting to OpenAI. It generates the creative content from the text prompts. It manages costs and usage efficiently, handles errors, and provides consistent results across all workshops. So I want you to go to this particular thing, which is the AI, and then you can see I have imported the AI client and then client.py. If you go here, first of all, you instantiate the logger for the AI client. Then you use your OpenAI API key and the Anthropic key from your env file so that it has all the keys available. And then if there's no keys available, then you just shift to a default simulation if this, so that it does not fails. Then we have this process text. Now we call this an API call. We log that as API call. Then we process text using AI ML services. So we'll come to the decoder request in a bit. But what does the decoder request will mean? We'll come to that in a bit. But this is what eventually we'll do, is we say that if there's a simulation, then we just simulate an AI call, which just doesn't give you any output. But if it's a real API call, then we call the AI.self API, self.OpenAI API, then we call OpenAI, right? And when you call OpenAI, then eventually this is a system prompt where we take the required task type, and then from this is whatever the task might be, and the user prompt, which is what is the prompt which is given, and the associated chunk. And then what you do, you have the model, you have the messages played into you must be knowing this, the maximum tokens, the temperature, all these parameters. And then what you do is you simply post that and use the HTTP and post on this particular API. And then you simply get an output, which is the output, what is the confidence, the token usage, the cost associated with it, the processing time to get that. Same we do for the Anthropic. I don't have the Anthropic key, so I have not really tested it out, but I've tested out this OpenAI, and then eventually it calls the OpenAI key, and if it's self-Anthropic, call open API, but if it is nothing, then you just simulate an AI call. And then you have the decoder response object. Now what it does, request ID, the output of that, the confidence which you have, the token usage, and the cost. So after the decoder's scraping is done, then you use an AI brain to be able to do something out of it. As you can see that I've also written that you connect your OpenAI integrations. Then you have the, OpenAI integrations. Then you have Anthropic integrations. Then we have a smart fallback system. So if then there's a simulation mode for development, if there's anything goes on, so we know, okay, it just does not breaks at all. And then we have task specific system prompts. So for example, if you just come over here at last, build system prompt, which is if the task type is this task type.qa generation, then you're an expert at creating high quality question answers. Basically the prompt which will be given to the AI system, and which we are using here, the build system prompt for that, where it tells based on the task type, it just gets you the particular system prompt. So basically that's a build system prompt for different systems out here, right? So let's say that you put in a request which is generate 3 QA pairs from the biology text, the input text, and the task type. What brain does, it routes to OpenAI, builds a specialized system prompt based on this particular system prompt, then sends an optimized request to an AI service using that OpenAI API client, then process and format the response into a decoder response into a particular object, which you can see over here, which can be seen over here in the particular format, tracks usage and costs and returns the professional unit as a single source. As simple as that, right? So this is what this AI client is trying to do. Now, why this is extremely good, I don't want to spend more of a time because I know that I rush at the end. The reason why, because you guys already have spent more and more number of time in starting only to make you understand the base and the context of it. So there are multiple AI services that's automatically routed to the right service, smart fallback system, consistent interface regardless of the provider, the robust error handling, retry, cost monitoring, usage tracking, performance, and everything which is going to be used in a Streamlit application. So I hope it makes sense, the AI client which we have developed. Now what we will do, we'll go to the next step, which is how we can quality control the lab, which is quality control pipeline, which we'll talk about in the next one. So now we're going to start off with our step number 10, which is step number 9 in this case, which is the quality control lab. Let me just see if this is working. And so, yeah. So what is quality control lab? Now we have generated the data, which is whatever the training data is generated from our task template, right? Now we need to also inspect every training example for the quality issues. We want to measure multiple quality metrics such as toxicity, bias, relevance towards the specific context, and approves high quality examples for use and rejects problematic content automatically, and provides a detailed quality reports for the improvement. So the architecture which we look out for is the quality evaluator. First of all, we initialize the document, basically logging, and then we say the quality metric which we're going to check, which is the harmful content, bias, variety, consistency, and topic relevance. All these things which we're going to check as a metric. So how does this really look like? So we asynchronously define an evaluate example, and what it does, it inspect a single training example. So what it does, it runs all the quality checks, which is check toxicity, check bias, check diversity, check coherence, and check relevance. And you can just go here and go to evaluation, and then you can click on evaluator, and then you'll finding all those code here. And over here, you calculate the overall quality scores based on whatever you have taken, and then you generate a detailed report based on that. So we check a toxicity and toxicity. And of course, I've not implemented this because you can use AI and AI client to be able to detect if it has toxic in nature and all. But there's one station 1, which is inspection stations, toxicity. Then you have bias detection. Then you have diversity, coherence verification, relevance testing, and etc. And what it does, that it gives you the quality report by the end. The quality report might be, okay, the target ID, the type, the overall score, the past, and the matrix scores, which we eventually get for everyone. And then you get a proper, nice quality report based off from your data. Of course, I don't get too much in detail because it is super simple to understand it, because I don't want to waste my time and your time as well to be able to tell you simple things, because it's a world of AI. Be involved into it as much as I can. And the reason why we do this is very simple, which is safety first. we should be able to identify that it's a responsible AI, and companies love it at times when you actually develop something like this. And then consistent excellence and the continuous improvement, which we eventually use via the quality tracking, metric analysis, and feedback loop, and optimizing the overall performance based on the quality data. I hope it makes sense completely. Now, pretty simple, right? It does not really has all the overall thing, but over here, we are just putting the mock quality evaluation from now on. What you can do, you can actually create multiple asynchronous sort of thing. For example, toxicity detection, then bias, then diversity, then coherence, then relevance, and other methods out here itself. And it eventually returns the object type, which is a quality report, given all these parameters inside it. So I hope it makes sense. Let's go to the next step, which we have, which is more interesting step. And now we have tested it. Okay, this is nice document, the nice data produced. Now we need to package it up and ship it, right? And that's what we're going to talk about the next one. So now we come to the next step, which is step number 10, basically. So what we're trying to do is we do have everything. Now we need to do is package and ship it. So basically, whatever we have training data into the particular object, we package it into multiple formats, which is JSON format, CSV format, packet, and etc. We want to label everything properly, like a metadata and the quality scores associated with each data set. We organize the data efficiently for easy across and delivers in your preferred format and tracks what was shipped for quality assurance. So this is our master packager. You can go to export, and this is a master packager where we instantiate our logger for the exporter. And then this is the asynchronous function, which eventually exports the data set using the following method. So the format is the given format is a JSON format, and the export format is again our object, which we have created in models.py. And then you return by using that export JSON into that particular format by giving the required arguments or parameters inside it. And then you have the CSV file, and then you'd have the same one, and then otherwise it defaults to JSON, as simple as that. Then you have the specific methods associated with export JSON. Then you have export CSV, and all those logic has been written around that itself. So then we have this, as I said, universal packaging, that if the export format is JSON, CSV, packet, Hugging Face, and of course I've not implemented much more into this project. So what I want from you is you should be able to implement multiple export format, and you'll see how extensible it gets by just replicating the CSV. And of course in the assignment file, you'll be also getting that multiple things which you do. That's why this is not whole, added with tons of features, because you ultimately have to add those features into this project. So this is it about the sort of thing, and I don't want to go in multiple details, but yeah, this is our step number 11, and step number 10. So I hope it makes sense. And this is our basically the base class where we are inheriting the database manager on that. So I hope it makes sense. Now what we'll do is we'll go to the step number 12, which is the professional web scout, which is the Decodo step number 11, which is the Decodo client. Now let's go to Decodo client, and just go to, because we have been always taking the name of this Decodo client, where you must be thinking, what does this Decodo client means? So this is nothing but an API client for web scraping and data extraction in a way that enterprise grade setting would work around. For example, let's say that you have a URL, and that URL, that's how we were able to, and we were using this Decodo client on and on into our project itself. And now here we go with an actual explanation around it. So what it does, it scrapes any website with a professional grade, extracts, cleans, handles error gracefully, processes multiple stuff, uses proper authentication, and support multiple locales and geographical targeting to bypass any bots. So we instantiate our logger. This is the base URL, which is where we are going to, this is an API endpoint where we're going to call by giving the URL to this particular endpoint. This is a timeout. There's a MAC retries and instantiation thing. And then what we do, we get authentication details from the environment. So we get those authentication details, and then we set up headers. Now, headers in this case, basically, which means that this is basically how we're going to call. So asynchronously, this is a base URL, this is a timeout, and this is a HTTP client, and then we just call it, right? And then what we say, we scrape the URL, right? Now, how does the scraping for the URL works? So if the target is universal, so all these parameters, and then based on the parameters, it makes the request to the Decodo API, and then post onto this V2 scrape on that particular endpoint, base URL, by calling this, and then it logs the response for the debugging, and then it returns those particular results into a particular format. And of course, it does all this work, which is remove HTML tags and all these clear white spaces, and then returns the standardized format after standardizing or cleaning the bit of text. Pretty simple, right? Now, and this is what it does. I don't want to get it again more in detail, but we do have an intelligent fallback system. So this is a professional scraping features. Then we have fallback system where it automatically falls back to simple stuff, which you have done in a web loader. And of course, we have been continuously using this. And then you have a parallel processing power that it can scrape multiple URLs at the same time. And I hope it makes sense. And then we have multi-target scraping. Then you have geographic and local support, and all this is supported by Decodo itself. And that's why we were able to come with a pretty nice examples of how we could do such things. I hope it makes sense. I hope because we have already talked about this, I don't want to get in much more detail. You can read more if you'd like, but this is it about the Decodo thing. Now, let me just see. Yeah, good. So now what we're going to do is we're going to work on command line interface. Those command line interface is based on a terminal. You can write those commands, and then that command will be doing by providing some simple commands for the all factor operations, not stream root application, but CLI interface, where you provide the simple text commands, process documents, generates the data, evaluates, and launches the dashboard for the visual thing. So what I want to go to the CLI, and CLI is eventually has everything, which is ini.py. So what it does, initializes the CLI API, training data curation bot, and then you have the command. So if somebody says process, it should be able to process the source directory, and then the output directory, the task types to be mentioned, the format to be mentioned, the quality filters, the number of max workers, and asynchronously doing it. Now, what eventually happens, the reason why we do this, we should be able to do it in the right way. So for example, the TDB process source directory, this is the documents available out there, and the output directory should be in results. Then you specify the task type. Now TDB process, from this source directory, the task type is QA generation. We're going to generate the QA generation dataset, and the task type is classification. Choose output format. We can choose the output format to be particularly CSV file. And all of this is possible if you're able to follow these commands to be able to do a particular set of tasks. Now, given that all these things are done, what I want, you can just go ahead, go through the process document async, and this is also very simple, right? This is pretty simple. It is not really hard to understand it, that what even one command does into this particular format is nothing but really asking, calling this and then calling a particular method from the class which you have created, and then doing things accordingly. So I hope it makes sense. Again, I don't want to really get into too much of detail, but yeah, that is it about the CLI, and I want you to explore by your own, rather than me going step by step, because it's super comprehensive. And you can just use GPT, because if I don't really explain one by one, but the whole point of this command line interface that we could interact with the project via the terminal itself, and we should be able to use it in a way which we aspire. And then we have our important, so coming back to our bot.py, and I've already explained to you what this bot.py does. It's just like a pipeline. Now we have the CLI. Now we have the dashboard, which is the most important part of it. And ini.py, basically, we have a dashboard where it says the stream root application, st.set page config, and then title, training data curation bot, the sidebars, and the dashboard, the documents, generate data, the analytics, the settings, and then for the dashboard page, we had all of this. So I don't want to explain all of this, but what eventually we're doing, we're creating the nice stream root application app from this. And again, all these are in assignments where we ask you itself to understand this very easily. It's very simple. What my main point was to help you understand the core part of it. The core part we have already completed, and the documents is there. Please go ahead and go through it one by one, and you'll be able to understand it much more detailed. We have made it super comprehensive at one time, and you should be able to understand how the whole application was built. I don't want to go in coding one by one details, but eventually we have created the 4 different tabs, and then for every tab we have the logic, and then we are literally calling the stuff from whatever we have created, core part of it. And then when you actually do one by line of line, the reading of the code, you'll truly understand where and what things are being used. I hope it makes sense, completely makes sense. We are done with the project. We are done with everything. What we'll do is we will finalize with our assignments, and you can find the assignment PDF in the description down box below, which simple stuff which we have created for you to work on. Work on that, And I hope you really loved this project. Explanation again, all this project source files and everything is available for absolutely free in the description brown box below. Go ahead, check it out. And then we catch up in the next one. And this is the end of the enterprise grade project which has ever developed on entire YouTube.